G'day there. In this video I'd like to show you how to use an induction meter or inductance meter to check the magnetic permeability of cores salvaged from unknown power supplies and places like that. Well, this one's got black inside, you can see through the wire there, but it does appear to be epoxy coated and it's probably not a ferrite core. So we need to get an idea before we use it in a joule thief or some sort of other induction project or choking project. What kind of magnetic permeability does it have? Does it have high magnetic permeability, which would make it ideally suited for a joule thief or boost circuit? Or does it have really low magnetic permeability, in which case it would be better used as a choke to reduce pulsing in a circuit? So what I've done is I've taken some lengths of wire, such as this one here, from a PC power supply loom, and I've made sure they're all exactly the same length, and I have actually zeroed one of these out in my meter. So to do that, we put it in there. Well, I did have it zeroed earlier, and the data's saved. It now says 0 inductions for a piece of wire. As you can see, if I touch it, the meter moves. I think you can see that meter there. I'll prop it up like that for you. If I put a loop in the wire, the inductance changes quite a lot. If I put a loop in the wire and stick a ferrite core in there, well, then the inductance goes up even further. So what we're really doing here is we're using a known length of wire, and you really should only use one. I'm using multiple pieces just to make this video short, so that you don't have to sit there and watch me unwind and unwind different cores. So you use one single known length of wire and something like a ferrite core with a known magnetic permeability as a control, and you measure that, and then you compare that reading to some of the salvaged cores. So that's what I've done here. I have a ferrite core that's very close to this random green one in size. Now, obviously a bigger ferrite core will give you different results to a smaller ferrite core, so you want to try and match your size as closely as possible. I'm not after super accurate results here, so this is good enough for me for my purposes. And I've wrapped both of these cores with 5 turns of the same length of wire. Same type of wire, same gauge. Both got 5 turns. So let's see what we've got. So my ferrite core here with 5 turns, if I pull that tight, it does change a little bit, but not a lot. Very small amounts of variation, that's not really going to affect me in a circuit. I have 17.8 microhenries, 17.9, depends if I pull it tight or loose. So nearly 18 microhenries. Now let's compare that to this dull green core. Dull green core has 554 microhenries. So anyone out there that's into high induction cores and stuff from PC power supply salvages, that green colour, pretty good chance it's going to have very high induction. That one's a little ripper, and I've got quite a few of those with bifilars wound on them, so they could make really nice little joule thief cores all ready to go. 4 terminals there, you just need to, if you wanted to make a joule thief from that, you would just connect a diagonal across those two and hook your base and your collector up on those two. That's simple. So you're thinking, well, I haven't taken the wire off, does that affect things? Well, I wasn't sure, so I did a test. I found 2 cores that were identical. Alright, there's this little blue one here with the wire on it. There were 2 of those. I took the wire off one. There is the wire that came off. I couldn't get 5 turns of my fat orange insulated wire through there, so I measured out 2 lengths of enamelled wire. In this case we're using 0.63 of a millimetre wire, which works out about halfway between 22 and 22.5 gauge for those that are interested. So now we can compare the same core, one with the windings that were on it from the power supply, like so, with one where I've taken the windings off to see if it's really worth doing it, because some of these cores, I'm looking at them and I'm thinking that wire that's already on there could be useful to me in many projects. do I really want to take it off? Like, look at this one, it's wound on really neatly. That's pretty thick wire. I could not get that wire on there that neatly by hand. It's clearly been done by a machine. Very neat job. I might be better off winding a second winding over the top of that and using that for one of my jewel thief projects. So, is there a difference? I found it to be very, very small. There is one, but it's tiny. So, for this core, with the windings, original windings taken off, I'm getting 2.23. I don't know if you guys can see that. 2.2 microhenries. I'm going to call that. I'm going to ignore the smaller numbers because it's just insignificantly small. And the one that's still got its original windings on also gives me 2.2 microhenries. It does give me a slightly higher number. Oops, I'm shorting things out on my meter there. It does give me a slightly higher number on the lower digits there by leaving the old wire on. But that's an insignificantly tiny amount. I mean, we're dealing with hundreds and thousands of microhenries. They're tiny numbers. It doesn't really matter for my purposes. It gives me an idea. So I can now go through with my known lengths of wire, and I can see what sort of, obviously this one's an air core, I can't measure the permeability of that core, but I can go through and I can check all these different coloured cores that I've pulled out of power supplies, and even this yoke I thought from a CRT might make a good inductor, if I tape it together like so. And I can see what sort of magnetic permeability I'm dealing with and find ones that are going to be suited to giving me really high levels of boost for my boost circuits that I'm playing with. Alright, that's about it. Questions and comments very welcome, and thanks for watching.